is that we've got our fluid property density, which is given the Greek symbol rho, okay, and that is a function of x, position, and time t. Okay, so density is a function of x and t. That's what that bracket x comma t means. Okay, now what we'll find later on is that we may need to calculate a partial derivative of a flow property, in this case density. Okay, and just remember, a partial derivative, we write that as d rho. So this is the partial derivative of density with respect to x. So that's the first component of the x, that first component of our position vector, bold x. Okay, so we're taking partial derivative of density with respect to that x coordinate. Okay, and so d rho by dx is formally defined as being equal to the limit as delta x tends to 0 of the density at x plus delta x, comma y, comma z, comma t, minus the density, at x, comma y, comma z, comma t, divided by delta x. Okay, so you'll see that if we're going to apply calculus to our flow property, it needs to be continuous because we need to be able to evaluate our rho function, our density function, at 2 points which are an infinitesimally small distance apart. So here we're evaluating the density at location x and also at x plus delta x, where delta x tends to 0. So in order to evaluate this derivative, we need density to be continuous. Okay, just note the definition of the partial derivative. We've got density is technically a function of 4 independent variables, x, y, z, and time. And if we're taking the partial derivative with respect to x, we allow x to vary and we hold y, z, and t constant. Okay, so you should have been taught that in your mathematics courses. Okay. Okay, so one final point here is that we may talk about fluid particles within our fluid or within our flow. And just remember, we're dealing with a continuum in fluid mechanics. So when I talk about a fluid particle, I'm not talking about a molecule or a group of molecules within the flow. I'm talking about a point within the fluid continuum. Okay, so now moving on to flow properties. So a flow is fully defined by its properties, and these properties are the fluid velocity,